In the space of science and massive secrets, the subject of what existed prior to the monstrous blast has sparked mixed discussions and captivated minds for a surprisingly long time. This tremendous question doesn't simply test how we interpret the universe. It challenges the very limits of human knowledge. Imagine standing at the edge of existence, gazing into the titanic shadows, and contemplating what lay there before our universe was born. The event of the Big Bang marked the dawn of time, space, and everything we know. But was there a moment before? Could there have been a state of nothingness, a silence before the cosmic symphony began? And if this is true, what if something far more unsettling existed before time itself? As we delve deeper into this question, science takes us on a journey beyond the universe's starting point into ideas that challenge our understanding. Physicist Brian Cox, known for his exploration of the wonders of the universe, suggests that something extraordinary could have existed before the Big Bang. He pushes us to rethink our perception of reality and existence. In this analysis, we'll examine the science, the theories, and the mind-bending mysteries that could explain what existed before everything. We'll explore ideas such as cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may shock you, but they could also open new interpretations of our place in the cosmos. Prepare to dive deep into a world beyond imagination, where science meets the shadows, leaving scientists amazed and, at times, even unsettled. Let's explore what may have existed before the Big Bang and why these theories challenge everything we thought we knew. To appreciate what might have existed before the Big Bang, we first need to carefully dissect what the Big Bang actually was. Scientists define the Big Bang as the moment when the universe became extremely hot and dense, expanding rapidly to set the stage for all matter, energy, and the fundamental forces. When we look at the night sky, we see evidence of this fiery beginning with galaxies spreading outwards from a central point. But why did this happen? And was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or quiet. Cosmic inflation proposes that before the Big Bang, the universe was in a state that was cold, empty, and free, essentially like a massive vacuum. However, this vacuum wasn't truly empty. It contained an enormous amount of energy that fueled the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it essentially laid the groundwork for everything to follow in a fraction of a second. Space stretching at unimaginable rates until inflation slowed and the energy transformed into matter, particles, and the forces we observe as the Big Bang. But what was the nature of this energy? Why did it suddenly expand the universe? And why did it stop? Scientists believe that this rapid expansion created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly with tiny bubbles forming here and there, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests that there are potentially infinite Big Bangs and an infinite number of universes. Ours is just one of many. This vast, mind-bending reality challenges our understanding of the very universe itself and leaves us with a question. What else is out there? The notion of nothingness before the Big Bang is speculative, at least per our current understanding. Even if you strip all energy, particles, and radiation from the universe, it still wouldn't be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and fundamental forces that weave a pervasive fabric of something. Even in its emptiest form, space itself has properties, rules, and constants that prevent it from being completely void. Imagine creating a region with literally nothing in it. No particles, no radiation, and no energy, except quantum fields and universal constants. These would still exist, suggesting that this nothingness has properties. For example, there is a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still briefly appear and disappear, creating a ghostly echo of activity even in what should be empty space. This challenges our concept of a true void and suggests that, yes, even before the Big Bang there was something scientists are only beginning to comprehend. One of the most astonishing theories in modern cosmology is the possibility of eternal inflation. If inflation could create our universe, it's conceivable that it could continue forever. Brian Cox describes an unimaginably vast inflationary multiverse where universes are endlessly created and continue expanding. Imagine each Big Bang as a spark igniting another universe, while inflation continues in other regions, creating countless other universes. This process could, in theory, happen forever. This idea of infinite universes gives rise to the fascinating concept of a fractal universe, where each new universe could create its own Big Bang. Each universe exists as a separate, independent region, unaffected by the others due to the rapid expansion of space. For scientists, this theory is both exciting and unsettling, as it suggests an infinite multiverse with no definitive beginning or end. Imagine our universe being just one tiny part of a colossal cosmic structure, ever expanding and constantly creating new universes. And what if the unsettling reality is that there is no before or after, but rather a timeless pattern of universes forming and decaying? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe isn't a collection of matter floating in space. Rather, it's a complex network of energy fields that permeate the cosmos, interacting to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they remain active. Particles can appear and vanish in these fields, momentarily gaining energy before returning it. This phenomenon results in virtual particles, entities that briefly exist and then disappear, leaving only a faint trace of their presence. The concept of virtual particles challenges the idea of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have total nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, fields remain active, sometimes creating fleeting particles. This constant activity in what we once thought of as nothingness reshapes our understanding of existence, suggesting that the universe, before the Big Bang, was far more complex and dynamic than we could have imagined. What ought to not be anything recommends that the universe doesn't perceive our idea of void. The fields and powers persevere, filling the universe with a secret energy that forestalls absolute nothingness. This understanding brings up a charming issue. Assuming fields make particles and particles make matter, might the actual universe at some point have risen up out of this nothing loaded up with quantum fields? Dark energy is a baffling power that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? According to certain perspectives, the fact that dark energy exists today is a remnant of an energy field from before our universe's development. The properties of dark energy appear to suggest a titanic, secret force that could have existed in some form prior to the Big Bang. Some theories suggest that dark energy, in a much stronger state, may have powered the inflationary phase, causing rapid expansion. The presence of dark energy suggests that even if our universe were depleted of all matter and radiation, this force would continue to expand the fabric of spacetime. This idea prompts a profound question. If dark energy was present before the Big Bang, might it have formed the conditions that led to the birth of our universe? Could dark energy be the silent architect of inflation, or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy as not only a force shaping our universe, but also a key that could unlock the secrets of the multiverse itself. Another theory that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology. The idea that the universe undergoes cosmic cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event but part of an eternal rhythm where universes expand, collapse, and then regenerate in a new cycle. This theory suggests that our universe could have been reborn from the remnants of a previous universe. The process of contraction and expansion in a cyclic pattern would imply that there was never a true beginning, but rather a timeless series of universes arising, evolving, and restoring themselves repeatedly. Cyclic cosmology raises significant questions about time, as it proposes that time itself might be cyclical rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give birth to our current universe. For scientists, this theory offers a profound answer to the question of ultimate origins, suggesting that there is no true beginning, The universe has always existed in some form, transcending our ideas of time and existence. Early-phase gravitational waves are another fascinating concept that could hold clues to what existed before the Big Bang. Gravitational waves are ripples in spacetime caused by massive cosmic events, and scientists believe that early-phase waves, if ever detected, could reveal insights into the universe's earliest moments. These waves could serve as echoes of what preceded the Big Bang. If they are identified, they could provide evidence of the universe's previous states. The potential discovery of early-phase gravitational waves is one of the most exciting possibilities in cosmology today, as it would not only reveal the truth about the Big Bang but also offer a glimpse into the cosmic state before our universe was born. This theory presents the tantalizing possibility of detecting gravitational waves that could act as fingerprints of a pre-Big Bang universe. As we continue to explore what might have existed before the Big Bang, we delve into concepts that push the boundaries of our understanding, challenging even our most fundamental assumptions about spacetime and existence itself. One of the most marvelous ideas comes from the domain of quantum gravity, a field that seeks to unite quantum mechanics with general relativity. This unification could potentially reveal a theory of everything and offer insight into what existed before the Big Bang. Quantum gravity suggests that spacetime and reality are not smooth, continuous entities as we experience them, but rather discrete, granular structures. This theory posits that the fabric of spacetime itself may have emerged from a microscopic, Planck-scale structure, with tiny quantum fluctuations shaping the universe in ways we cannot yet fully comprehend. In this view, what we perceive as the smooth continuum of reality would have only emerged from these fluctuating quantum fields. Thus, the before the Big Bang could be characterized by a fundamentally different nature of reality, one where space and time themselves were not yet fully developed. Another possibility is that our universe is part of a vast cosmic landscape of potential universes, each with different physical laws and constants. This theory, known as the string landscape, arises from string theory, which suggests that all fundamental particles are actually tiny vibrating strings. Within this framework, there are many possible configurations of these strings, each corresponding to a different set of physical laws. The string landscape could imply that our universe is just one of many, each arising from its own unique Big Bang-like event. The existence of such a landscape also raises the idea that other universes could have different dimensions, different strengths of gravity, or even different types of matter. In this view, our universe might not be unique but rather part of a multiverse, a collection of universes, each evolving independently. The multiverse theory provides a speculative yet fascinating answer to the question of what preceded the Big Bang. Another universe in a different configuration, potentially leading to endless cycles of creation and destruction with no definitive beginning. In addition to these cosmological models, some theoretical physicists have considered the role of black holes in shaping the concept of the universe. A hypothesis gaining attention is that our universe could be the result of a black hole formed in another universe. In this scenario, the singularity at the center of a black hole could act as a gateway to another universe, with the Big Bang being the moment when such a black hole gave birth to our universe. This hypothesis is supported by the fact that, according to general relativity, the singularity at the center of a black hole is where spacetime curves infinitely, creating a region where the known laws of physics break down. It's possible that the extreme conditions within black holes could lead to the creation of new universes, which may suggest that what we consider the Big Bang was simply the birth of our universe from the singularity of an ancient black hole. Exploring these ideas requires a deep dive into the very nature of time itself. Some cosmologists hypothesize that time, as we understand it, may have had no meaning before the Big Bang. If time began with the Big Bang, then there may have been no before in any conventional sense. According to this view, time itself would have emerged from a quantum transition or from a primordial state where the usual distinctions between past, present, and future did not apply. This could lead us to rethink the nature of causality, which relies on the understanding that events occur in a linear sequence. If time did not exist in the way we experience it, then the question of what came before the Big Bang becomes meaningless, as there would be no temporal framework to support it. Ultimately, what existed before the Big Bang remains one of the most profound mysteries in science. As our understanding of quantum mechanics, cosmology, and fundamental physics evolves, new theories will continue to emerge, offering increasingly complex, and sometimes paradoxical explanations for the origins of our universe. While we may never fully grasp what came before the Big Bang, the pursuit of this knowledge will continue to push the limits of human curiosity, driving us to explore the unknown frontiers of existence.